So now we're going to talk about visualizing 2 and 3 forms. Both methods, or visualizing both 2 forms on R3 and 3 forms on R3 are generalizations of how we visualize 2 forms on R2. So let's discuss that first. 2 forms on R2. So essentially, 2 forms on R2, I mean, they're all some function times dx wedge dy. But it's easier to think about them when we're talking about visualizing them as wedge products of 2 one forms. So if I have alpha wedge beta, where alpha and beta are 1 forms on R2, then what I do to visualize them is I draw the visualizations for alpha and beta on top of each other. So let's do just the example of dx wedge dy. So in this example, let's think of it at a point. For dx wedge dy it doesn't really matter, but d by dy. So here I'll draw my visualization for d by dx, or for dx. And then, so I'm drawing all the level sets where dx of vectors that end on these level sets or on these lines are integers. And then the same thing for dy. And then I'm also going to add one extra thing, which is a counterclockwise a notation that says counterclockwise. So what does that mean? Basically, that means that if I draw, okay, so what I can pair dx with this vector, whoops, this vector here, which is like the sort of simplest vector. It's a vector that is on the 1 level set of d by dx that is on the 0 level set of d by dy. So there's going to be one such vector, and then I'm also going to take the similar vector for dy. So it's on the 0 level set of d by dx, or of dx, and on the 1 level set of dy. So it's d by dy. And then if I go from the my first element in my wedge product is d by dx. So I start with the pink vector first, and then I want to travel to the orange vector. I go in a clockwise direction. So that's why I decorate this grid with a little clockwise, or sorry, I go in a counterclockwise direction. So that's why I decorate the grid with a little counterclockwise spiral. So what does this mean? This means that if I want to compute dx wedge dy of, let me actually do this in a different color so I can really show you what's going on. I already used purple. Let's use brown and dark green. So dx wedge dy of u comma v is the area of the parallelogram spanned by u and v. But it's not just the area, it's the signed area, and the sign has to do with this little spiral arrow I drew. So I'll make that red to remind you. And then it also has to do with, it's also scaled. And the scaling has to do with the orange and pink vectors. So I'll label that in that way to remind you. So let's say u is like this vector and v is maybe this vector. I should draw that as a straight line. Then I can draw the parallelogram that they span. So it'll be that. And dx wedge dy applied to u and v is the area of this parallelogram. And because u comes first and v comes second, and to get from u to v I go counterclockwise, I'm going to measure it with a plus sign. And the scaling here won't have any effect, but I will show you where it does have an effect. So if I were to take the wedge product of 2 different forms, so let's do 2 dx wedge dy, then I would have, so this is again at TPR2 some point, then I'm drawing all the same level sets for d by dy, or sorry, for dy, the one form dy. But now my level sets for dx should come twice as thickly. So I should also draw this one. I should also draw this one, right? Because now when the d by dx coordinate is 1/2, dx will evaluate that to 1. So now, okay, so I still have my same. So now I don't have the exact same pink vector, but my orange vector is the same. My getting from pink to orange is the same. But now what I've done, so if I use the same u and v vectors, so that should be u should now be here, v should now be here, and I obviously didn't do things perfectly, so it doesn't look quite the same, but it should be these are the same sort of u and v. I'm measuring this area, the same parallelogram, with the same sign, right? Because to get from u to v, I'm still going counterclockwise. But now I need to measure it where I've scaled area, like the whole concept of area, so that this block is area 1. So what that means is I'm going to double the area. So the sign. So now we understand what the sign is. If when I go from u to v, it's the same as going from sort of the pink vector to the orange vector, then it's a plus sign. If it's opposite, it's going to be a minus sign. We'll do an example of that in a moment. And then the scaling is I measure it so that the block determined by the pink and the orange vectors is area 1. So another example, let's do dx plus dy, wedge 2 dy. In this case, I'll have, so again, d by dx, d by dy, TPR2. So now I have my, I should have every two, or every, I should have twice as many level sets for dy, and then my level sets for the first, form that I'm doing should be the level sets for dx plus dy. Okay, so now my pink vector, right, it's on the 1 level set for dx plus dy and the 0 level set for d2 dy. And then my orange vector is on the 1 level set for 2 dy, but the 0 level set for dx plus dy. And again, I'm counterclockwise, and then I'm scaling, all my areas so that this parallelogram has area 1. And say now I want to compute, I think, what was I doing? Brown first, the area of, say, let's have u equal that, and v equal this vector. Now I'm having my parallelogram over here. So should be something like this. Now I'm going to have a minus sign, because when I go from u to v, I go clockwise. And so how am I going to generalize this to when I vary p, I can use either of the methods to visualize the one forms. Maybe it's easier to use the second method. So as an example, let's do x dx plus dy, wedge dy. So I had my x and y axes, and I have all my little sort of parabolas. as the level sets as the kernel of that one form, and then for dy, my level sets are here. And you'll notice that this doesn't actually quite work along the x-axis, and that's because I have dy wedge dy, which is 0. So ignoring sort of what's going on at the x-axis, this means that, so if I'm, I use kind of the wrong colors, but let's just think about our what our sort of basis vectors, our pink and our orange vectors should be. So at this point here, I need to be moving over one level set, one pink level set, but staying on the same purple level set. And then for orange, so I should sort of linearize this or think of it as being linear and be sort of going in that direction. So near this point here, I'm measuring area where essentially this parallelogram has area 1, and I'm counting the area with a positive sign. Actually, this is a good opportunity to make the point that if I have the vectors going in the opposite direction, so say I'm at this point, then I would be measuring area with a negative sign. So the area will be scaled the same because basically this parallelogram is like the same area as this one, but the signs will be different. Okay, so that's how you visualize two forms on R2. Oh, one more thing. So this is not unique, right? So all two forms on R2 can be written on R2 are of the form f of xy dx wedge dy. And this, I can write this as a wedge product of two one forms in a bunch of different ways, right? I can write this as like, this is like f of x y dx wedge dy. I can also write it as dx wedge f of x y dy, or I can write it as the square root of f dx wedge the square root of f dy, or I can also write it as, f dx plus 17 dy wedge dy, right? Because dy wedge dy is 0. So this is not unique, but it can help you think about different ways to visualize what's going on.